So we've gone through all the vocabulary, and it's a little overwhelming. It's a lot of terms. And so what we're going to do now is kind of look at the difference between some of the terms. A lot of the terms are one thing or the other. And so we're going to look at some examples of parameters and some examples of statistics. Remember, parameters are values from a population. The important part is that whatever number you're talking about is coming from a population. It doesn't really matter what the number is, it's that it comes from a population. So when you see the phrase, "it is known that 49% of all students on campus own a car," that number, 49%, is a parameter because it's coming from all the students. They somehow got all the students' information, and they know that 49% of all students on campus own a car. So that 49% is coming from a population, so it's called a parameter. The next one says 12% of the 50 governors of the United States are female. Couple giveaways there. The first thing is the word "the." That refers to all of them. And the fact that it's 50. And we know in the United States there are 50 governors. 50 states, 50 governors. So of the 50, that means that this 12% is referring to the entire population. Another example of parameter, the average score on the departmental final exam is 72%. So that's the number for all students enrolled in calculus on campus. So again, that keyword "all" is referring to the entire population of students that are in calculus. On the next one, it says only 12 men have walked on the moon. Their average age at the time of their walks was 40. So the average of 40 is coming from all 12 men. Only 12 have walked on the moon, and if you average all 12 of them, it's 40. So the 12 men is your population, so those are the only ones that have walked on the moon. And the last example of parameter, Ty Cobb has a career batting average of .366. So career is referring to all of his games had that batting average. So those are examples of parameters. You're looking for some keywords. They're not always the same word, but keywords that indicate that the numbers that they're referring to are coming from a population. The other type of values that we study are called a statistic or statistics. These are values that come from a sample. So each example is referring to the same topic, but one is from a population and one is from a sample. So for the parameter, it was all students on campus. For the statistic, it says in a sample of 100 students on campus, 46% of them own a car. So the 46% is coming from a sample, whereas the 49% is coming from all the students. So if the number they're referring to is coming from a sample, we call it a statistic. The next one also says in a sample of 30 states. We know there's 50 total, but in a sample of 30, 20% were female. So that 20% is called a statistic because it came from a sample. On the next one, this number was for all students in calculus. This other number, 65%, is only from a sample of 50 students on campus. Most of the time it says the word sample. I don't want to say always, but most of the time it says the word sample. The next one says in an interview with 5 of the men who walked on the moon. So only 5 when there was 12 total. So usually when you interview, you don't get everybody, you just get a small portion. So with an interview of 5, their average age was 45. So that 45 just came from that sample of 5, not everybody. And the last example, Ty Cobb's career batting average is a parameter. Ty Cobb had a batting average of .24 in 41 games. So that's a sample of his career. So that's not all the games he played in, it was just a portion of them. So again, if the number is coming from a sample, it's called a statistic. If it's coming from a population, it's called a parameter. So in your homework, you'll have different examples, and you'll decide, is that number coming from a population, is it a parameter, or is it a statistic from a sample? Some other vocabulary terms I want to distinguish are qualitative versus quantitative. So remember, qualitative is called categorical values. Sometimes this is referred to as this or that, where you classify things into different categories. Quantitative variables are referred to as numerical values. These you either count or you measure. So discrete, you count. Continuous, you measure. So these are just some examples. Some of them are from the book. Some of them are ones that I've come up with. Gender would be a categorical variable, either male or female. Birth month would be categorical. You were born in this month or that month or this month. So you'd sort them into categories. The brand of phone that you own, again, would be separated into different categories. Favorite food would be separated into different categories. The state you were born in, if you were from the United States, would be in different categories. Zip code is one of the ones that can be a little tricky. Even though zip codes are numbers, we're either in this zip code or we're in that zip code. We don't average zip codes. That doesn't make sense. So you're either in this one or that one. Same thing with area code, like for phone numbers. Again, that's a categorical variable because you either are in this area code or that area code, one or the other. So if you can classify things into one or the other, then it's a qualitative variable. Numerical variables are numbers that you would count or average or measure. These are things that you would tally up, and it would make sense to average these numbers together. So the number of cars through the drive-thru at Whataburger is discrete. You either have 0 cars, 1, 2, 3, etc., and you could have an average number of cars through the drive-thru. Same thing with points scored by a player in a basketball game. That's also a count. So you scored 0 points or 1 point or 2 points or 3 points, and you would count how many points were scored by that player in the basketball game. And again, it makes sense to average these values. Same thing with number of students who passed the first exam. I could have 0, 1, 2, 3. That would be a count of how many passed. And I could have an average over the semesters. And finally, number of goals scored by a team for a particular season. Again, that would be a count, 0, 1, 2, 3. You would count how many goals were scored, and it would make sense to average those numbers. So these are called discrete quantitative variables, where you count how many of this, how many of that. Continuous quantitative variables are measurements. So volume, you would measure the volume. Height, you would measure the height. Temperature, you would measure the temperature. So it wouldn't be 0, 1, 2, or 3. All of these values, including concentration of a contaminant in water, all of these values could have decimals and fractions. And you can get more and more and more precise with decimals and fractions. So measuring volume of water can get very, 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 very precise with a lot of trailing decimals or fractions. Same thing with height, temperature, concentration. Anything that you measure could have infinitely many possible values because you can get more and more precise on your measurement. So if it's something that you measure, it's a continuous variable. If it's something that you count, it is a discrete variable. So they're both quantitative, but discrete and continuous are two different types of quantitative variables. There's a little bit in your book about level of measurement. There might be a homework question on level of measurement. It will not be tested, but if you want to read about it, it's on page 9 of your textbook. Again, there might be a homework question about it, but it will not be assessed on your exams. All right, we are moving on to section 1.2. What I would like you to do is pause the video. I'm not going to read these to you. Pause the video, read the first scenario, read the second scenario, and compare and contrast them. Think about what's the difference between the two scenarios. You can jot down some notes here, or you can just think to yourself, after reading the two scenarios, what is the difference? So just pause the video, take a few minutes to read those two and compare them. Alright, so once you've read those two scenarios, one of them was an observational study, that's the first one, and the second one on the bottom of the page was a designed experiment. So we're going to talk about section 1.2 is the difference between an observational study and a designed experiment. We don't spend too much time on this, it's not a huge part of the course. I just need you to be able to recognize the main differences between the two. This is more, if you're going on to graduate level research, you will take more courses in having observational studies or designed experiments depending on your discipline and what you're trying to research. Alright, so observational studies are kind of what I call hands off. There's no attempt made to influence the individuals. And again, your book goes into more details if you'd like to pull up section 1.2. But there's no attempt made to influence the individuals in the study. We're measuring results without influencing the variables. Again, I'm just kind of paraphrasing here. So there's really no attempt made to influence the individuals. This is where you would just conduct a questionnaire, or you might just gather some data without changing anything. I might just pull transcripts, or I might pull whatever kind of data I need without changing anything about the individuals. So I measure my results without influencing the variables. So this is kind of a hands-off approach, just gathering data, just an observational study. Designed experiments are more hands-on. You're doing something, you're manipulating something, you're messing with things. So the individuals are intentionally influenced. So we're going to do something. We're going to test you with something. We're going to make you do something you wouldn't normally do. We might have you try a new food or a new medicine. We're going to change something about you on purpose. So intentionally influenced. In the example with the rats, they were intentionally exposed to that radiation. So again, it's very intentional. We're intentionally changing or influencing the variables, the characteristics that we're trying to measure. We're intentionally changing them before measuring the results. Before measuring the results. And I'm sure you've seen this. Maybe you've been asked to complete a questionnaire before. They do this a lot with retail, with food. You're asked to fill out questionnaires after you buy something, either online or in the store. You're just asked to complete a questionnaire. Design experiments require a lot more time and intention. I know sometimes people are asked to participate in some of these experiments. If there's a new medication they're trying to test out, or a new product, you might be asked to change something about what you're doing, so that's more of a designed experiment. So there's a couple different types of variables that come up when we start talking about running experiments and conducting observational studies and gathering data. There's some new terms that come up, and you might be slightly familiar with these two terms. The first one is explanatory variable. This is the value being, value is not a good word, variable is a better word. It could be a value, it could just be a characteristic, being manipulated or changed for the experiment. So the explanatory variable is generally considered your input. Think of it as your input. So we're manipulating something for the study or the experiment. And then you've got your response variable, which we consider the output of the experiment. And that is the variable or value being measured at the end of the experiment or the study. What are we trying to measure at the end? So you've got your explanatory variable, your input, your response variable, your output. If you've taken an algebra class, your explanatory variable is what we call the x variable. The response variable is what we consider the y variable. We'll talk about that more in Chapter 4. There's not too much algebra in this course. It just kind of brushes on some basic algebra. So our goal, either in a study or an experiment, when we're trying to gather data, we're trying to determine how varying or changing the amount of an explanatory variable, whatever we're trying to measure, affects the value of the response variable. So how much medication should I give you? This amount, this type, that type. It could be food, could be physical exercise, it could be all kinds of things. So we're going to manipulate or change the input and see what happens to the output. And if you watch the show Mythbusters, they do this all the time. They have all these different inputs. They test them at different levels or different types, and they somehow measure the output. So there's a lot of different ways that this can happen. So one thing that's not in your textbook that I do just kind of want to briefly go over are some pros and cons to observational studies and some pros and cons of designed experiments. They touch on this in the book, but I just want to go over it briefly just to give you a sense of when is it a good idea to do an observational study or a bad idea, when is it a good idea to do a designed experiment or a bad idea. Again, this is just kind of touching on what you would get into if you were to do your own research. So some pros of observational studies. The first pro is that it's very easy to implement. Write up a questionnaire, send it out. No harm done, doesn't cost very much money, very easy to implement. So it's less expensive in both time and money. Businesses consider time an expense, so in both time and money, it's less expensive. Doesn't take as much time, does not take as much money. It also doesn't take as much personnel. If you're trying to get staff to help you out, it doesn't take as much staff to run an observational study. Another thing that's really good about it is it's very low risk. You're just asking people to answer some questions, or you're just going to go observe what's currently being done without hurting anybody or changing anything or ruffling any feathers. So it's very low risk to run an observational study. There are some cons to observational studies, and the main one is called confounding. And we'll talk more about this here in just a minute down here. Your book gets into confounding as well, but that occurs when two or more variables are not separated. So sometimes when you're collecting data, things get kind of muddied up. Like maybe you're trying to study student preferences when it comes to class times, but something else gets in the way of your results. I know a couple semesters ago we tried to conduct a survey about the atmosphere on campus. And so we were just trying to talk more about the lighting and the color and just the general energy of the building. And in our observational study, we got a lot of feedback about faculty and parking and traffic and all these other factors, all these other variables that we weren't considering in our study. And it kind of muddied up our results. So confounding is when you're trying to collect data about one thing, but other things are also part of your observational study that you did not intend to look into. So that's called confounding, kind of mixing up your results. So another way of saying that is that the results from the study could be due to factors other than what you were trying to study, other than the explanatory variable. And that's the big con about observational studies, is that you don't know what you're going to get when you do an observational study. You don't know what kind of results you're going to get, and you don't necessarily know the reasons behind those results. So the one thing the book talks about is that it cannot show what they call causation, meaning one thing causes another to happen. It can only show association. So we can say, yeah, these two things are related to each other, but I can't say that this one input caused this one output. We can't make as bold of statements with observational studies. So again, there's a little bit more about confounding in your textbook. I don't want to over-explain myself on the videos because I know it can be a little confusing. So I do encourage you to go back and read in your book about confounding. Confounding is caused by what we call a lurking variable. So lurking is kind of hidden, if you think about it, kind of lurking behind other variables or other things. So it's an explanatory variable that was not considered in the study, but it affects the value of the response variable. Oh, I didn't think about that, or oh, I didn't realize, that was part of my results. So it's kind of a hidden variable that you didn't consider in your study, but it did affect your results. I'm going to go ahead and stop there, and then in the next video I'll pick up with some pros and cons on design experiments.